the quantum experiment that broke reality. At the heart of quantum physics lies a paradox so strange, it challenges the very nature of reality. This mind-twisting revelation emerged from a simple but profound setup, known as the double-slit experiment, a doorway into a world where certainty collapses and reality becomes fluid. Imagine firing tiny particles like electrons or photons at a barrier with two narrow slits. On the other side lies a screen that records where each particle lands. When only one slit is open, the particles form a single band, behaving like solid objects. But when both slits are open, the particles mysteriously create an interference pattern, as if they were waves passing through both slits at once and interfering with themselves. Here's the twist. Scientists decided to observe which slit each particle went through using detectors. The moment observation occurred, the interference pattern vanished. The particles reverted to behaving like solid objects, forming two distinct bands. Somehow, the act of observation changed the result. It was as if the particles knew they were being watched and adjusted their behavior accordingly. This shocking outcome flipped classical physics on its head. It suggested that particles don't have fixed properties, like location or momentum, until they're measured. Instead, they exist in a superposition, a mix of all possible states until observed. This birthed the Copenhagen interpretation, led by Niels Bohr and Werner Heisenberg, asserting that reality itself is shaped by observation. To illustrate this strangeness, Erwin Schrödinger proposed a thought experiment. A cat is sealed in a box with a radioactive atom, a Geiger counter, and poison. If the atom decays, the cat dies. But quantum theory suggests the cat is both alive and dead until someone opens the box. The idea may be symbolic, but it captures a disturbing truth. Quantum systems remain undefined until observed. The implications are vast. Does reality depend on consciousness? If so, what constitutes an observer? A human? A machine? This debate stretches the boundaries of science and philosophy alike. In the 1960s, physicist John Bell deepened the mystery with Bell's theorem, testing whether particles are linked in unseen ways or follow hidden rules. His experiments, called Bell tests, confirmed that entangled particles affect each other instantly over any distance, defying Einstein's theory that nothing can travel faster than light. This spooky action at a distance means the universe is non-local, and perhaps more interconnected than we imagined. Then came the Wigner's friend thought experiment, adding another layer. In this scenario, Wigner's friend observes a quantum event inside a lab. To the friend, the outcome is fixed. But to Wigner, who hasn't yet observed the friend or the result, both remain in superposition. This suggests multiple conflicting realities can coexist, each valid to its observer. These experiments aren't just philosophical, they underpin quantum computing, cryptography, and other emerging technologies. The idea that particles can exist in multiple states at once allows for incredible computational power, but they also raise chilling questions. What is real? Is reality objective, or do we co-create it just by experiencing it? In the end, the double-slit experiment and its quantum siblings tell us something humbling. We don't understand reality as well as we thought. It may be that our world, at its deepest level, is built not on certainty, but on probability. And the line between the observer and the observed is far blurrier than we ever imagined. As Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics. But in that mystery lies a kind of wonder, an invitation to explore a universe stranger and more beautiful than fiction could ever imagine." Like and subscribe.